Hello guys, this is Narajan and welcome to my channel. So in today's video we're going to talk about my personal favorite physicist, Sir Albert Einstein, because today is his birthday. So happy birthday, sir. So today is also Pi Day, which I have made a video already on it. Like you can see it. I have provided the the options there at the top where you can click and watch the video. When I have calculated pi to it's a surprise. Okay, you just see that video. So in today's video we're going to talk about Einstein's life and mostly my favorite part, the physics part. We're going to divide it into three parts, like four parts. First, his life. Second, his Nobel Prize winning idea of photoelectric effect. Third, special theory of relativity. Fourth, general theory of relativity. So here are the four things. Like if you want the four things, like I'll have the timestamps in the description. So let's get started. So first, what is Einstein? Where is Einstein born? Okay. So Einstein is born in Germany, Ulm city, and then at the age of 15 months, okay, his family moved to Munich. There, his father had a business of electricity, like light bulbs, and then it went bankrupt. And by the age of 15, when Einstein was 15, his family moved to Milan, keeping Einstein in Munich. There, he faced a lot of, unfair treatment. He felt isolated. He felt like kind of, alone on his head. He had a bad mental health, so he planned to just have an excuse of bad health and move to Milan, where his parents shifted with his sister. There he stayed for some days, I guess, and then he moved back to. He didn't move back, but he moved to Zurich in Switzerland. There he had his education done. There first actually went for the entrance test, which he failed. Like he failed botany, he failed politics, he failed zoology, he failed French, he failed literature mostly. So he passed mathematics and physics nicely, but all the other subjects he failed, which caused him not to get admitted to the Zurich Polytechnic University. There he shifted to his father's friend, whom the professor advised him to. The professor of the university, physics professor, advised him to stay there, learn from a physics teacher there. So to study from him, he had to stay somewhere nearby. So he stayed with his father's friend's family. So there he used to learn French from the daughter of his father's friend. And then he had nice relationship with the physics teacher. That physics teacher had always allowed Einstein to think outside of the box. And then he passed his examination, went to Zurich Polytechnic, did his graduation, and there he met Mileva. He got attracted to her, and then both of them were quite of nerds, quite of that. Like they were kind of physics people. So then Einstein, married her. Before that, what happened was before he married in 1903. So in 1901, he used to work as a teacher. Okay, he used to teach students. Then 1902, he was a clerk, And then 1903, he got married. Okay, 1902, 1903, 1904, 1905, he published his 4 papers. Okay, so on electrodynamics of moving bodies, relativity, and then there were more. So and then I'll explain each of them. After that, in 1905, he published it. 1915, 10 years after, he developed his general theory. So he didn't develop his theory of general theory of relativity by then. It was only special theory and this photoelectric effect and 2 other papers. So he developed his general theory of relativity in 1915. Then in 1919, one of his British friend, his name was Eddington. He had to prove his theory of general theory of relativity. So through solar eclipse, which happened in May, rare events that time. So he using that he verified it. I'll tell you how in the later video. Then in 1921, I guess he got his Nobel Prize. in physics, not because of theory of relativity, but because of photoelectric effect. Then he continued his journey, and then many people from quantum mechanics pop out, like not pop out, but came out. And then we had Niels Bohr. Rutherford did his discovery in 1933 of neutron, nucleus, and then Niels Bohr came, Schrödinger, Dirac, and a lot of people born. So then quantum mechanics developed. So Einstein has a major role in quantum mechanics. That's what I'll explain. He used Max Planck's principle of E equals to hf to, postulate about that photoelectric effect. Okay. So, and then we had 1940s, 1950s, where there was like Niels Bohr versus Einstein. That will be a major section too in this video about Niels Bohr versus Albert Einstein. That's going to be quoted. Okay, Schrödinger. Okay. Then we have, and if you want to see quantum mechanics, we have again the option top. I have made a video on basics of quantum mechanics, so you can see it. And then what happened was in 1950, he passed away in 1960s actually, and then 1954, 1955, I guess, maybe. I don't remember the date, but it's like in the same decade. Okay, and then I'll tell you a funny incident which happened in his life that when he died, Niels Bohr said that nice because he just said that now Albert Einstein is bad because he used to always be against quantum mechanics, which he developed and all that stuff. And like this is after 10 years after his death, after Albert Einstein's death, and just 1 to 2 days after, Niels Bohr died. Like people, in a funnier way, say that Albert Einstein just came down, got angry. He's like, you used to debate with me when I was alive. Now I'm dead. Now why are you spreading stuff like this? So like you also come up and then we'll debate there. Like that. Okay. So this is about Albert Einstein's life story. Yeah. Also about the transfer to USA. What happened was in 1940s, Nazism came in Germany. So Hitler used to hate Jews, and Einstein was a Jew, so Einstein felt threatened there. And he also knew about the atomic bomb model. There were Germans who were creating the atomic bomb there. So he warned Franklin Roosevelt, the president of America, about it. So and then he got American citizenship because of his stuff. He hated Germany's Nazism ideology. He was against it, and also in 1919, I guess, 1918, 1919, he divorced with love of marriage, and he married his cousin, Elsa Einstein. And then Elsa Einstein was a smart person too. She helped Einstein in many of his theories, to bring many of his theories. And Elsa told him to move to USA initially 1940s, 1939, 1940s. And then Albert Einstein was against it because he loved to teach his students there. And then after a lot of discussions and debates, he finally agreed to move to America, where he was in the Manhattan Project with Oppenheimer. There he developed, he didn't develop, but he's E equals to mc squared. Okay, that's the big one, the big formula. It's actually a small part of a big formula. Okay, so yeah, he developed because of that equation and some of his physics. They developed a nuclear bomb and then dropped on Hiroshima and Nagasaki. And Albert Einstein was against destruction and war, so he voted for peace in United Nations. He wrote a letter which didn't go as planned. Nobody listened to him. And then he died in 1950s. So this is his life. Okay, so let us discuss about first thing I told about is photoelectric effect. So what is it? Okay, so let's go to Planck. Max Planck. Okay, while solving the algebra catastrophe, by mistake you accidentally discovered that E is equal to hf. Okay, he didn't know that it was particle, photons existed. Okay, but what did Albert Einstein do? Okay, he said that this thing, okay, the metal here with electrons. People have a lot of controversies on this effect also. People say it didn't depend on color. It depended on color. Some say it didn't depend on color. Some say it depends on the say intensity. So people said intensity affected number of electrons emitted, but after experiments showed it's wrong. Intensities don't affect it. It's nothing. Intensity is with amplitude. Okay. So if this is a wave, the amplitude of a wave affects intensity. because intensity is a direct proportion to amplitude squared. Okay, but the thing was frequency was causing this. So what was his theory? That instead of a wave, which was proved by Young in the Young's double slit experiment, I have mentioned in my new radioactivity and Nobel Prize video. So Young proved that light is a wave, but Einstein like no, light is not a wave; it is chunk of energy. Okay, and each chunk has energy of E equals to hf. E is equals to hf. E1 f1, E2 f2, like that, and they all sum up to give energy. So now this is one packet, and this packet he called as photons. Now more energy, more frequency. So red light will kind of do less effect, and blue light, not less, I mean blue less effect relative to the blue light or violet light. And then we had electrons emitted, who's with v velocity. Okay, so then Einstein gave his formula. So what is the first one here? That total energy is equals to wave function plus kinetic energy of the electrons. Wave function, no, not wave function. Sorry, my bad. It's work function. Work function. Yeah, that's the name of it. Sign out. Okay. Not wave function. My bad. Wave function isn't quantum mechanics. It's work function, I guess. Oh, I don't know the name. Yeah, it's work function. It is like the threshold frequency. Yeah, that's a better name. Threshold frequency required for it to happen. E can be. Let me just erase this. E can be written as hf. This can be written as threshold energy, not frequency. Sorry. H. Okay, so this thing is hf naught. This is threshold energy is equals to threshold frequency into Planck constant. And then we have this thing plus kinetic energy, half m of electron v squared. Then we bring that side, and then we have f minus f naught is equals to half mv squared. And then we can find out the velocities of electron. So this is photoelectric effect. Here he did something which is known as quantization of light. Not unknowingly, but he did something which acted as a seed to quantum mechanics. The seed will grow into a big plant, a big tree, which is quantum mechanics, which will be against him only. He didn't know that. Okay, yeah. This is quantum mechanics, how it began. Einstein's photoelectric effect. Okay, that's why I typed it as genius. Why? Because he's genius. Like nobody can. Not nobody can beat him. Newton was smart. Like all physicists are smart in their own way. But I am obsessed with Albert Einstein and his life. So yeah, I like him. Yeah, the second one. Okay, the second thing he did was my favorite, Special Relativity. So SRTR. Here we have many concepts. First, let's begin with the first concept, which says Lorentz transformations. So he said that, I just do in short, that this is something frame 1, S1, and the person standing here, frame 2, S2. My bad. S2. So according to him, not him, Galileo, according to Galileo, there were some transformations he gave, okay, which were, I think x is equals to x, we will do this, x plus, let me just have a moment. Okay, yeah, so I wrote in the book, x dash, my bad, is equals to x minus vt. And then he said, this is Galilean transformation, okay? Galilean. Not Lorentz, okay? Lorentz was done by Einstein. Mathematics was done by Lorentz. The thing was done by Einstein, okay? Physics stuff. and then y, and then z is equals to z, and t is equals to t. This is the first done by Galileo. But as Einstein said, time is not the same as we think. It's mischievous. It's mysterious. Okay, but time is not as we suggest. It is. Okay. Now, let us do what did Einstein do? He gave some Lorentz transformations. So what are they? First Lorentz transformation was same as the Galileo, but with this gamma. What is gamma? Gamma is Lorentz factor 1 minus p square by c square. Okay, and then he said, this is same, but for time also he gave one more. Okay, gamma. Okay, he gave first t plus vc square, so vx by c square, sorry, vx by c square, another meter per second divided by second square meter square, second meter, wait, what? This is answer, vx square, I'm not wrong. Just see once, and doubt if I teach you wrong. I don't want to teach you wrong, it's okay, just be happy with that. Yeah, it's correct. Let me just see. Yeah, I knew. I messed up with the sign. If it's not correct, it's just minus sign. Okay. So t dash is equals to gamma t minus vx by c square. Okay. These are the four Lorentz transformations. 2, 3, 4, and this is. I'm not going to teach you entire relativity here. So this is the four Lorentz transformation, and with this transformations, he gave a lot of formulas. Time dilation, t gamma. Okay. Then he gave length contraction, L by gamma, and then the energy is equals to, say, momentum, first of all, momentum is equals to, what should I do first? Mass. So mv square. Why? He said that this is relativistic mass, and then this is equals to the rest mass here, m naught. Okay, and then if you put this here, we get this mc square. I'll tell you. Okay, this is not the true equation. This is a part of the equation. Okay, the true equation is E is equals to E square is equals to p square c square plus m naught square c to the power 4. This is the true equation. This is a part of our equation. What do you mean? Okay, the light is a massless particle, so momentum, so mass is equals to 0. That means energy is equals to Pc for light. Okay, and if you take P as h by lambda, de Broglie. Lambda is equals to by P, so yeah, h by lambda, hc by lambda. What is it? hf. So E is equals to Pc from this. Okay, we have verified it. And then if it is not light, if it is a person or an object in rest, the momentum is 0. Then E is equals to mc square. This is m naught c square, but it actually should be mc square. Okay, this is the formula. Okay. Now I hope you are. This is m, not m not m. This is a formula. Okay. This is the some formulas. Now he also gave a velocity formula. Okay. I'll explain you these things like little in a while. So he gave that v is equals to v minus u. V dash is equal to v minus u, and then we have 1 minus v u by c square. Alright. Yes, this is the formula of velocity transformation. Yeah, I have to check one. I don't want to teach you. Right? Who likes to teach them? Yeah, correct. Okay, yeah, correct. So this is the formula. V dash equals to v minus u by 1 minus v u by c square. So we have a lot of formulas, okay? Let us discuss them one by one. This, okay? This is not relativity class, this is just introduction to it. I know this is a lot for introduction, but just bear it. If you want a detailed class like quantum mechanics for relativity, I'll give you. Time dilation. According to Einstein, light is a maximum speed limit. Okay, he drew a light cone. Okay, one more concept, a light cone. This is light. This is the this thing I drew 45 degree from the axis is light. Here is everything else system. Okay, now this is light. Okay, everything else is existing here in the inside this. Okay, light cone. This is a light cone. It's a hyperbolic space. Okay, so that's GDR. Sorry, I just came. Okay, so according to him, light is the fastest thing in the universe, which travels with the speed of 3 times 10⁸ meters per second. So he said that as you go and reach the limit of light, okay, your time slows down. Okay, so it's like you are moving at very high speed. The time slows down for you, not for the person that's next to you. Hope you can see the board now. It's visible. Yeah, so as we were discussing about time dilation, as you move faster and faster, your time gets slower and slower in respect to your time frame or like frame of reference. Now, if you consider about length contraction, this one. Length contraction says as you go faster and faster, your length gets shorter and shorter. So what we discussed, as you go faster and faster, time gets slower and slower. So your time increases. As you go faster and faster, length decreases. So there's something constant. Length is decreasing, light time is increasing. That constant is your speed of light. Okay, that is why we are invariant. Okay, like if I have to explain everything here, like it would take ages. So invariant is nothing but something which is constant for all frame of reference. Its value del s is equals to del x square plus del y square plus del z square minus c square del t square. Okay, so write it. This is the invariant. This is the invariant, okay? Now, this is about special relativity, okay? Then we have this velocity addition. So if you have two people traveling at 80% speed of light, what will you see? You won't see as 160% of speed of light. You will see as speed of light. Because if you plug the value here, you get speed of you won't get speed of light. If you have to, then we use plus. Okay, it is plus and minus both. Okay, here in that case, when you are traveling in the same direction, use minus, and if you're traveling at different direction like this, it's adding up. Okay, so if you like this, and it becomes 0.8, 1.6 c divided by 1 plus we use 0.64, and then we get 1.64 by 1.64, which is let me just see. Yeah, the answer is 0.97 c, 97 feet of light, percent of speed of light. And then we have this formula, E equals to gamma mc square, which says that basically energy and mass are the same thing. Let us remove this gamma for reduction of confusion. So E is equal to mc square. So energy and mass are equivalent. So I have mass, I have energy, not kinetic energy, not potential energy. I myself have energy. And then this equation is same as this one for momentum, and this is derived from this as I explained you. And then yeah, nothing is left. STR is completed, just like this. Now we talk about GTR. Actually, it has a lot of stuff. We have 4 vectors and stuff, but we cannot discuss about it right now. That will lead us to tensors and that stuff. In GTR, okay, we have many phenomena which Einstein predicted. Okay, so what is it? Okay, so according to Einstein, this is a matrix of space-time fabric. Okay, now if I have a mass, it will curve it. Okay, it will curve it like this, It's not straight. It will like this. Anna. It will curve it like this, okay? You can see it. Okay, yeah. Yeah, it will have something like that. It will curve like this. So it will curve the spacetime in a way that now we have this. ये बॉलम क्या को मग this समझ नहीं आ रहा मुझे. So this curvature creates cavity. So if you have anything here, it will start orbiting it. If you have anything here, start following it. If you put a velocity here, okay. So according to it, okay. If you have a straight path, that's accelerating frame, and if you have a curved path, that's non-accelerating frame. Okay, it's a hyperbolic space. As you can see, it's like geodesics. You have seen the latitudes and longitude converge at poles. Similarly, same concept here. Then what we have is GTR. It's a lot big, huge concept. Okay, like we have something as gravitational lensing. So it is the angle calculated by it. So the formula is theta is equals to approximately 2v square by c square. Okay, this is I have done this formula because I feel it is more appropriate, but the real formula is 4gm c square r. I just converted into this. Okay, yeah, same thing. And then we have Mercury's pressure plus precession. Okay, you have sun here. This is Mercury's orbit. It precesses every time. It is like it is the orbit is shifting by small degree. Meanwhile, for Venus, it's not the case because of the strong GTR effects here. This has been proven, as I've told you, in 1919 solar eclipse. Sun was covered, and then we measured the position of star. I made a video on gravitational lensing. If I'll put the link, I put the option there. And then what we have? Then we have lensing time. Redshift. So according to this, the curvature, it shifts the light's frequency. So it is high frequency light here. It redshifts it into a lower frequency light. And then what we have? Gravitational redshift. And then I think the formula is F by F. Okay, there is not a lot of formulas here. And then we have what we have. Yeah, then we have Einstein's equation. Okay. So G mu I'll write it after erasing. Okay. So and then what we have? I explain all the effects here. Then what we have? Lensing, redshift, precession, and what? I think this is most of it of GTR. Yeah, it's based on curvature and tensors. Okay.
We also have gravitational time dilation, which is like at a point the gravity of a object influences the time dilation of it. The formula is T dash is equals to del T by 1 minus 2gm by c square r. Okay, yeah, this is the only thing which I forgot in the video.
For it right now, I'll make a second video if you want. So now the equation I'm talking about is AG was it? What was C by 4? There's one more thing I forgot. It's AGM, I guess. No, it's 8G 8 by G. And then T mu. Right, this is the
Yeah, I have used eta here and not new. I'm mispronouncing as new every time. That's wrong. It is eta, not new. I am using eta because it is more convenient for me to write. It's actually new if you write for real equation, but I'm writing it as eta because that's more convenient for me. It's just symbol change, nothing else has changed.
yeah, this is our Einstein's equation. This is so you can relate it to F is equals to M. How? This is A. This is 1 by M. Actually, it's not M. This is 1 by M. This is A. So if you put it like this, A is equals to F by M, or 1 by M into F. This is your force, the stress tensor. This is a mass, one over mass. Sorry. And this is acceleration, the gravity. So this is actually the formula. How is it related? this thing you can see here is 10 to the power 40 minus 43. So the mass is nothing but 10 to the power 43. So to bend this space-time, okay, by a unit answer, okay, you would need 10 to the power 43 kg. That's a lot of mass. Okay, so that's more mass, almost like 10 to the power 13 times more than sun's mass, or 10 to the power 11 times less than universe's mass. That's a lot of mass. Okay, so this is what is required to curve it by a unit test tensor. And this is what is it? This is what it's about. Okay. Then we have Einstein Bohr debate. Okay, so what happened was Schrodinger came with his Schrodinger's cat, Bohr came with his quantum model. So Einstein like, no, how is it possible that if you look there's nothing, but if you like don't look there's everything? That makes no sense. That's catastrophe. And then Bohr is like, no, it is possible. And Einstein is like, no, how can it be probabilistic? And then Bohr is like, it is probabilistic because if you do something, that depends on the path you're taking and the probability of it happening. The Einstein's like, no, God doesn't play dice with you. God doesn't play dice with us. And then Bohr said, don't tell the God what to do with the dice. And then, yeah, that is the most famous part of the debate. And then they met in, I think, in city, I forgot. It's in Czech, I guess, Czech Republic, I guess, Czechoslovakia. Maybe, no, I think Belgium. Maybe just check once. So, like, okay, it is a city. Okay, all the physicists. Okay, I don't know. I forgot the city. You can just put the thing in the comment section. The city's name. There, all physicists met. Whether it is your Einstein, Niels Bohr, Schrodinger, Dirac, Marie Curie, Born, Planck, everyone met. And they were talking about how quantum mechanics can affect the world. It can affect the world very, very nicely, in a positive way. Okay, and yeah, the relativity time dilation is very useful in GPS. How clocks are synchronized. There are many problems in GTR and quantum mechanics which is not solved. How to merge the gravity from quantum mechanics, which I am trying to work on, but it's very hard. Okay, just see. Yeah, it's very hard to do. Okay, so this is about today's video about Einstein. Thank you. Bye bye.